Hi, my name is John Kroc-Malling, and I have developed these visual tutorials to accompany any technical training format that might be delivered. In this presentation, we'll explore electrical components making up electrical circuits. There is one learning outcome associated with this presentation. Number 1, name and describe electrical circuit elements. There are 4 elements to an electrical circuit. They are the power source, the load, and conductors. The power source is just that. It supplies electrical energy to an electrical system. We can remember that an electrical voltage pressure difference is necessary to initiate a flow of electrical current. This represents the motive force, or electrical pressure, to initiate electrical flow. And as we can remember that any flow is necessary upon a difference in pressure. A higher pressure measured at one end and exposed to a lower pressure located at the other end results in the flow of matter. One common power source is line voltage available in duplex receptacles. The L1 portion has the 120 volts of electrical pressure. The neutral, or N, portion has 0 volts. In this graphic, the GND, or ground, portion is also considered to have 0 voltage. Transformers are another commonly found source of electrical power. Transformers come in a variety of voltage sizes and applicable to certain electrical circuit applications. It is important to understand that electrical transformers convert between higher and lower voltage values, but keep the voltages in alternating current, or AC, form. Transformers can be step-up, step-down, or isolation-type transformers, depending upon circuit requirements. Power supplies are similar to transformers in that they convert a higher voltage down to a lower voltage, and they are different than transformers in that they convert alternating current AC voltages to direct current DC voltages. Common power supplies found may power notebook computers, where one cable of the power supply plugs into a 120 volt power source and the other cable plugs into the computer to power it. The transformer section is between these two cables. Also shown is a common power supply available for automation enclosures. Batteries are another type of power source. The voltage of a battery comes from the chemical energy making up the battery. The battery voltage is identified as direct current, or DC voltage. Notice that batteries come in standard voltage capacities, such as 1.5 volts, 6 volts, 9 volts, and 12 volts. All electric circuits must have loads that accept the electrical power and convert that power into another energy form. Electrical loads provide the work using electrical energy, and as it does so, it consumes energy. Electrical loads offer resistance to the flow of amperage. In this graphic, we see 3 common electrical loads: a lamp, a motor, and a resistor. As mentioned previously, loads convert one form of energy to another. Lamps convert electrical energy into heat and light. Motors convert electrical energy into rotational mechanical torque. Circuit resistors convert the electricity into heat and slows the current down as the current passes through it. All electric circuits have sources of power and loads. Conductors are those circuit components that connect the source of the electrical power to the loads that intend to use it. Conductors provide a pathway for the amperage flow. Conductors can take many forms, such as actual wiring and cable. They may also apply to wire terminal blocks, switches, and contacts. It is important to understand that conductors do not convert one form of energy to another. This is the responsibility of the circuit load. conductors convey the electrical power to the load. To recap what was learned, all electrical circuits have a source of power, a load, and conductors to connect the load to the power source. The ladder diagram shown features all three components necessary for an electrical circuit. We can remember that transformers are considered a power source and is logically located in this drawing at the top of the diagram. Electric loads are identified and are intended to convert electrical energy into other energy forms. Electrical conductors, as you see, are used between the loads and the transformers.